Okay, 1.1 deals with families of functions, describing transformations of parent functions and describing combinations of transformations. So, functions that belong to the same family share key characteristics. The parent functions is the most basic function in a family, and functions in the same family are transformations of their parent function. So here we have a constant, which a constant function is not going to have an x in it. So a constant is just going to be some number. So we know that f of x is the same thing as saying y. So our constant would just be y is equal to some number, or f of x is equal to some number. A linear function is going to have an x in it. It can look like x plus 5, x minus 2, 3 times x, something like that, but it's always going to have a single x. So the x isn't going to be squared, it's not going to be cubed, it's just going to be a single x. The absolute value graph is always going to be the absolute value happening to x. So we have the absolute value of x. It could be the absolute value of x plus 3. It could be the absolute value of x minus 2, something like that. But that x is always going to be inside the absolute values. And our graph is always going to be this V-shaped. And then lastly, we have a quadratic graph. So anytime we have an x squared, our graph is going to be U-shaped. So we could have x squared plus 5, or like x minus 2 squared. We still have that x that's being squared, so it's a quadratic graph. So these are just our 4 parent functions. So looking at our first example, we need to identify the function family to which f belongs, compare the graph of f to the graph of its parent functions. Without even looking at this function here, we know that this parent function is going to be an absolute value graph because it has this V shape. So we already know that this is an absolute value. Now by looking at this, f of x is equal to x2 times the absolute value of x plus 1, it kind of just solidifies that it's an absolute value graph because the absolute value is happening to the x here. So anytime we see that in an equation, we know that it's going to look like the absolute value graph. Now our regular absolute value graph, if we just had the absolute value of x, it would start at the origin and go up like this. So comparing our graph of f of x to the parent function, what is happening here? How would we compare these two? What's the difference? So what's the difference between the blue graph and the pink one?
It's lower.
Right, the pink one's lower. So when describing our f graph, we would just say that it's shifted up. So we take the parent function and shift it up. And it's kind of hard to tell from here, but it's a bit narrower. So we can say shifted up and more narrow. Looking at our next example. Identify the function family to which g belongs. Compare the graph of g to the graph of its parent function. So what family is this going to belong to?
The quadratic.
Quadratic. And our quadratic graph would look like this. So what's the difference between our blue graph and our pink graph?
Wait, how do you know it looks like that?
We'll graph it in the next couple examples, but we can see here that it looks like this. But it'll be easier to compare in the next couple of examples you'll see as we go on. How would we compare these two?
It shifts more to the left.
It shifts, so we're going from our parent to our function, so it actually shifts to the right.
Oh, okay.
And it's wider.
And it's wider, so it shifts right. And we can say it shifts right 3 units, and it's wider. Okay, so now we are describing transformations. A transformation changes the size, shape, position, or orientation of a graph. One type of transformation is a translation, and it shifts a graph horizontally or vertically, but does not change the size, shape, or orientation. So going to example 2, graph g of x is equal to x minus 4 and its parent function, then describe the transformation. So here we're going to graph the parent function and the function that's given to us. So never mind. First we're going to graph the parent function. So we see that there's an x all by itself, so we know that this is linear. So what we're going to do is plug in values for x and get y values. So when we plug in -2 into this equation here, what do we get for y?
-6.
Into the equation, y is equal to x.
Oh,
-2. Awesome. So our x is going to be the same as y. So going to our graph, -2, -2, when we plot that point, we go to the left 2 and down 2. We do the same thing for -1. So when we plug in -1 into our equation, we get y is equal to -1. So we go to the left 1 and down 1. We plug in 0 and we get 0. We plug in 1 and we get 1, and then we plug in 2 and get 2. So our graph of our parent function is going to look like this. Next, we need to graph the function that's given to us. So we're going to graph this x minus 4. So we need to plug in x values to get y values. So when we plug in -2, we have -2 minus 4, which is -6. So we're going to go to the left 2 and down 6. Next, we plug in -1. So we have -1 minus 4, which is -5. Good job, Miss Carver. So we go to the left 1 and down 5. Next, we plug in 0. We have 0 minus 4, which is -4. So we stay at 0 and go down 4. Then we plug in 1. And we have 1 minus 4, which is -3. And then 2 minus 4, which is -2. So our graph of our function is going to be this blue line. So what type of transformation is happening here? So we're going from the pink line, the parent function, to the blue line.
Translation.
A translation. And how is it, what type of translation? How are we moving it?
Down.
How many units?
4.
4. Awesome. So the way I always think of it is I take the same point, so I'll look at 0, 0, and then just see that this point here is 0, -4, so I see that our graph just shifts down 4 units. So this is a translation that shifts down 4 units. So keywords here are translation and shifts. Next we have a reflection, which a reflection is a transformation that flips. So here our keyword is flips. A graph over a line called the line of reflection. A reflected point is the same distance from the line of reflection as the original point, but on the opposite side of the line. So looking at our next example, we have p of x is equal to -x squared, and we need to graph the parent function. So our parent function, since we see that this x is being squared, our parent function is just x squared. Okay. So now we're going to plug in x values and get y values and graph our parent function. So we have -2 squared, which is 4. So our first point is going to be to the left 2 and up 4. Next we're going to plug in -1. What's -1 squared? 1. So we go to the left 1 and up 1. Next we have 0 squared, which is 0. 1 squared, which is 1, and 2 squared, which is 4. So we're going to do the right 2 and up 4. So our graph of our parent function is going to be this parabola here. Now we're going to graph our p of x is equal to -x squared. So we're going to plug in the same numbers. But now we have this negative that's outside of our exponent. So we have negative times -2 squared. So it would be negative times -2 squared. -4, awesome. So we're going to go to the left 2 and down 4. We do the same thing for -1, so we have negative times -1 squared, which is -1. So we go to the left 1 and down 1. -0 squared is just 0. What about -1 squared? -1. And -2 squared? -4. So what type of transformation is happening here? A reflection. And to be more specific, what axis is our axis of reflection?
The x-axis?
The x-axis. So we can see here, our axis of reflection is going to be this line. So this is the x-axis. Any questions on that one? All right, let's move on to the next. So here we're going to be graphing n of x is equal to negative absolute value of x. So our parent function is going to be this absolute value of x. So remember, absolute value makes whatever number is inside of it positive. So even if it was a positive number, it just keeps that number positive. So we have the absolute value of -2 would be
2.
2. So we go to the left 2 and down, and up 2, sorry. So left 2, up 2. What's the absolute value of -1?
1.
1. So we go to the left 1 and up 1. What's the absolute value of 0?
0.
What's the absolute value of +1?
1.
1. What's the absolute value of 2?
2.
2. So our parent function is going to look like this. Now we need to graph our function that it gives us. We have this negative absolute value of x. So the negative is on the outside, so we have negative absolute value of -2. What would this be? -2. So when x is -2, y is -2. What about the negative absolute value of -1? -1. Negative absolute value of 0 is 0. What's the negative absolute value of 1? -1. And the negative absolute value of 2? -2. So our graph of our function is going to be this pink line. So what transformation's happening here?
It's a reflection of the x-axis.
A reflection of the x-axis. Perfect. So we see that our line of reflection is this line here, and this is the x-axis. Okay, next page. Another way to transform the graph of a function is to multiply all the y coordinates by the same positive factor other than 1. When the factor is greater than 1, the transformation is a vertical shrink. So a vertical stretch, my bad. A vertical stretch happens when it is greater than 1. When a factor is greater than 0 and less than 1, it's a vertical shrink. So a vertical shrink happens anytime that it is a fraction. So a number that's greater than 0 but less than 1 is going to be some type of fraction. So looking at our first function that it gives us, we have g of x is equal to 2 times the absolute value of x. What's our parent function for this? The absolute value. So the absolute value of x is our parent function. For this one, I'm going to take out -1 and 1, we really don't need 5 points to graph. For the homework, I'm only going to make you graph with 3 points, so I'm just going to take those 2 out for the sake of time. So the absolute value of -2 is what? 2. So our point on our graph, we're going to go to the left 2 and up 2. What about the absolute value of 0? 0. And what about the absolute value of 2?
2.
So we're going to go to the right 2 and up 2. So our graph is going to look like this. Next we have our function that it gives us. Just by looking at this 2 times the absolute value of x, what do you think is our transformation that's happening here before we even graph it? What do you think our transformation is?
Gonna be 2 times bigger.
It's going to be 2 times bigger, but what did we say these 2 types of transformation here are? We have a vertical stretch or vertical shrink.
Or did be a vertical stretch?
A vertical stretch. And we can tell that just because this 2 is greater than 1. So before we even graph it, we know that the transformation that's happening is a vertical stretch. But let's graph it just to see. So we have 2 times the absolute value of -2. What's 2 times the absolute value of -2?
4.
4. So we're going to go to the left 2 and up 4. Next we have 2 times the absolute value of 0, which is 0. And then 2 times the absolute value of 2. 4. So we're going to go to the right 2 and up 4. So we see that this graph is being stretched this way. So it's being stretched vertically so it becomes narrower. Next we're going to graph b, which is h of x is equal to 1/2 x squared. Looking at what's given to us, what type of transformation do you think is happening?
A vertical shrink.
A vertical shrink. So we don't even need to graph it to tell that a vertical shrink is happening. Okay, so again, I'm going to take out -1 and 1 just for the sake of time. And we know that our parent function of this graph is the x squared graph. So this is a quadratic because we see that that x is being squared. So what is -2 squared?
Four.
4. So when we plug in -2 for x, we get 4. So we go to the left 2 and up 4. Next we plug in 0. What's 0 squared? 0. And then last we have 2 squared, which is 4. Good job. So we know this graph is going to be U-shaped because it's x squared, so this means it's quadratic, so it's going to look like a parabola. So it's going to be U-shaped. Next, we're going to graph our actual function, which is 1/2 x squared. So we have 1/2 times -2 squared. What's 1/2 times -2 squared?
2.
2. Awesome. -2 squared is 4. 4 times 1/2 is 2. So we're going to go to the left 2 and up 2. One half times 0 squared is 0. And then we have 1/2 times 2 squared, which is 2. So we're going to go to the right 2 and up 2. So our graph is going to look like this. So it's just a little bit wider than it was with our parent function. And we said that this is a vertical shrink. Any questions here? Oh, we still have one more on this page. Any questions from these two? On the left here, it's like a helpful tip. So to visualize a vertical stretch, imagine pulling the points away from the x-axis, and to visualize a vertical shrink, imagine pushing the points towards the x-axis. Let's take a look at the last example on this page. So we have 3 times x, so we know our parent function is going to just be x. So this graph is going to be what type of graph? What family does this graph belong to? Linear. So this is going to be a line, a straight line. We're going to take out -1 and 1 again. So we have when x is equal to -2, y is -2. So we're going to go to the left 2 and down 2. When x is 0, y is 0. And when x is 2, y is 2. So we're going to have a straight line like that. Now to graph our function, we have 3 times x. So 3 times -2 is what?
6.
-6. So we're going to go to the left 2 and down 6. Next we have 3 times 0, which is just 0. And then lastly, we have 3 times 2, which is 6. So we're going to go to the right 2 and up 6. So our graph of our function is going to look like this. So it's more steep than our graph of our parent function. What type of transformation is happening here?
Rotation.
Nope. Looking at this, our parent function is being multiplied by 3.
Vertical stretch.
A vertical stretch. So because our parent function is being multiplied by a number that's greater than 1, it's a vertical stretch.
Is that all we have to put for that explanation, or do you have to put like the amount it moved?
Nope,
to the
just the vertical stretch. So you would only put the amount if it's a translation, if it's being shifted in some direction. So if it was like being shifted down 2 units, then yeah, you would put the explanation there. But here it's just a vertical stretch. Any other questions from this page? So here we have a combination of transformations that's occurring. This says to use a graphing calculator, but we're going to graph it on our own. We have g of x is equal to negative absolute value of x plus 5 minus 3. So what would the parent function be here?
Absolute value.
The absolute value. So our parent function is going to be this absolute value of x. It's going to belong to the absolute value family. We're going to plug in, let's plug in -2, 0, and 2. So when we plug in -2 for x, what do we get for y? positive 2. So remember, the absolute value of negative 2 is positive 2. So we're going to go to the left 2 and up 2. The absolute value of 0 is 0. And the absolute value of positive 2 is what?
2.
2. So we're going to go to the right 2 and up 2. So our parent function graph is going to look like this. Next, we're going to graph negative absolute value of x plus 5 minus 3. So the numbers that we're going to plug in here are going to be negative 7, negative 5, and negative 3. And I'm just giving you guys those as a helpful hint of what to plug in just to make it easier. Since it says to just use a graphing calculator, but we're good enough to graph it on our own. So first we're going to plug in negative 7. So we have negative absolute value of negative 7 plus 5 minus 3. What do we do first here?
Negative 7 plus 5.
What's negative 7 plus 5?
Negative 2.
Negative 2. So what's the absolute value of negative 2?
2. 2.
And what's 2 times negative?
Negative 2.
Negative 2. And then what's negative 2 minus 3?
Negative 5.
Negative 5. So when we plug in negative 7, we get negative 5. So we're going to go to the left 7 and then down 5. So that's our first point on the graph. Next, we're going to plug in negative 5. We're going to do the same thing. So we have the negative absolute value of negative 5 plus 5 minus 3. What's negative 5 plus 5?
0.
0. What's the absolute value of 0?
0.
0. And then what's a negative times 0?
0.
0. And then what's 0 minus 3? Negative 3. My pencil would work. I would write it. Let's see. All right, so plot the next 2 points on your own, and then we'll do it together. I just need my pencil or finger to start working. Three down, which gives us the graph we need. Perfect. So I think you only have one like this one on the homework, but the rest are like the ones before. On the homework, it'll ask you to graph the function and the parent function. So just plug in 3 points for each of those. So you don't have to do the 5 that we were doing before, but just 3 points for each. Any questions on this? All right, last page.